Hi there. Today we are going to continue our discussion of molecules, and molecules are compounds that are made entirely of nonmetals and contain covalent bonds. Today we want to discuss ABE notation and molecular geometry. Now you will notice that the letters A, B, and E are all capitalized, which usually indicates that something is an acronym and it stands for something else. In this case, we're going to learn that the A stands for the central atom of the molecule. The B stands for the number of atoms bonded to A, which notice I have emphasized atoms because it's the total number of atoms, not the total number of bonds around A. And E stands for the number of unshared electron pairs on A. Again, I've emphasized pairs, not just the individual dots. Why is ABE notation even useful, and why do we talk about it? Because ABE notation allows us to predict what shape a molecule is going to have in real life. When we draw Lewis dot structures, they are on paper and they're flat, but real life is not two-dimensional and flat like paper, it's three-dimensional. So what we did today is we made a note card about ABE notation to help us. So those of you that are on remote learning, I would highly encourage you to pause the video and copy this table onto a note card right now. So you're gonna have 4 columns and 6 rows. The first column is gonna be for ABE notation. The second is for the shape that's associated with that, then bond angle and hybridization. All right, so for example, in the first row, you have AB2, which is a linear shape and has a bond angle of 180 with a hybridization of SP. So like I said, I'd take a minute, pause the video, create your own note card. If you don't have a note card, you could just write this on a sheet of paper because you're going to be able to use this on quizzes and tests from here on out, and it will be very helpful for you. Additionally, on the back of the note card, we have 2 extra shapes for the expanded octet types of molecules, which are more complicated. You have AB5, which gives you a shape of trigonal bipyramidal, and AB6, which are octahedral in shape. You don't have to know the bond angle or the hybridization for either of those 2 molecules. I just would like for you to have them there for your reference. Once you have your note card made, we're going to go through some practice problems. So the practice problems on your skeletal notes say, given the Lewis dot structure, determine the molecule's ABE notation, shape, and bond angle. So I've kind of skipped through the skeletal notes that you have, just give you the molecule, HCN and pH3. You've got to come up with the Lewis dot diagrams. I had posted solutions for those on Google Classroom, but we're going to skip ahead for the sake of time here. And I'm going to provide the correct structure for you and teach you how to determine its ABE notation. Okay, so remember, A stands for the central atom. So if this right here is the correct Lewis dot structure for HCN. We put carbon in the middle, by the way, instead of nitrogen because carbon likes to be in the center. I tell students that its symbol is C because it likes to be the center. You could, in theory, put nitrogen in the middle, but in real life, carbon's going to be in the middle. So in this case, carbon is what is in the center. So when I write A for this molecule, I'm talking about carbon. Next, we're going to write a B. And B, as our note said, is supposed to tell us the number of atoms that are bonded to A. So if I look at carbon, we have a hydrogen and a nitrogen atom bonded to it. So that is AB2 because there's 2 atoms bonded to the central atom of carbon. Now E is supposed to stand for unshared electron pairs on carbon. And if I take a look at carbon, there are no dots on carbon, so there's no E in the structure. All right, so my ABE notation for HCN is AB2. So I go up to my table and I find the line for AB2, and I read across. The shape of an AB2 molecule is linear, and it has a bond angle of 180 degrees. So that's what I'm going to add to my answer down here, because it said to give the shape and the bond angle. So AB2 has a bond angle of 180 degrees, and a shape that is linear. Sorry, I got those out of order. All right, next we have pH3. After you work through it, you will find that the correct Lewis dot structure for pH3 has phosphorus in the center, surrounded by 3 hydrogens and 1 lone pair. So in this case, my central atom is going to be phosphorus. This is going to be an AB3 because I have 3 hydrogen atoms bonded to that phosphorus. And this time we have a lone pair on the phosphorus, so AB3E1 is my structure. I go back to my note card. AB3E1 is right here on the note card. It says that's trigonal pyramidal, and it has a bond angle of 107. So trigonal pyramidal, bond angle of 107. Now I could on a quiz or a test ask you for the hybridization of that, so you would just read in the table and it says the hybridization for those molecules is sp3, but we're not going to work too much on that today. We will cover that tomorrow. All right, sample 3, CCl4, the correct structure is drawn right here. What is the central atom? The central atom is carbon, so our A stands for carbon. B, how many atoms are bonded to that carbon? There's 1, 2, 3, 4 chlorines, so an AB4. There are no dots on the carbon. Students frequently ask me, wait a minute, Mrs. Goebel, there are dots here. Those don't count because all we want is the dots that are on A, your central atom, and there's no dots on that carbon, so there's no E. AB4, we go back to our note card. AB4 says that we have a tetrahedral molecule and an angle of 109.5. So tetrahedral and an angle 109.5 degrees. The next sample, we've got water, H2O. When you draw water correctly, this is what it should look like. Your central atom is oxygen, so A stands for oxygen. B, there are 2 hydrogens bonded to that oxygen, so I've got a B2. And E, now remember, we're not counting the total number of dots, we're counting the pairs of dots. So I have 2 pairs of dots. A, B2, E2 would be the correct ABE notation. Go back to my note card. A, B2, E2 is right here. So that gives me a bent shape and 105 degrees. Now, someone in class asked me today, you might notice that there are 2 different hybridizations because there's 2 different ABE notations that will give you a bent structure. If you have an AB2E, it has a hybridization of sp2. If you have AB2E2, then its hybridization is sp3. So those are written that way for a reason. Regardless, this molecule that we're working with is a bent structure, and it would have an angle of 105 degrees. SiO2 is your next example. Once you draw the correct Lewis dot structure for SiO2, you will notice that the central atom is silicon. So silicon is our A. B, now remember, it's not the number of lines around this central atom, it's the number of atoms bonded to it. So you've got 2 oxygens around that silicon, AB2. There are no dots on the silicon, so there's no E's. So our structure is AB2, which is linear, if you look back at your note card. And the bond angle for that is 180 degrees. All right, let me change my ink color so that you can better see for this solution. All right, sample number 6. We have boron in the center with 3 iodines. Now remember, boron's one of those double your luck elements that we talked about yesterday. So it doesn't need a full set of 8 electrons around it. It's happy with the 6 that are drawn around it right here because it started with 3. Regardless, our central atom this time is boron. So that's a little confusing because A stands for B for boron in this case. So A is boron. There are 3 iodines that are bonded to that boron, so it's going to be B3, and there are no lone pairs on that boron, so there's no E. I go back to my data table. AB3 is right here. It tells me that it's a trigonal planar shape with 120 degrees as the bond angle, so trigonal planar, 120 degrees. So the main takeaways here are you have to have a valid Lewis structure in order for this to work, and it's really, really helpful to have that note card so that you can predict the ABE notation, the shape, and the bond angles. Again, please make sure that you use your note card and create your note card. I will be posting the associated homework assignment tonight on Google Classroom.